So it is important for us to distinguish between economic significance and statistical significance. We'll take a look at this baseball example a little bit later. But what I want to emphasize here is that when we are doing hypothesis testing, whether we are looking at t-tests or we are looking at p-values, that is purely about statistical significance. Okay, it is really not speaking to whether a variable has some sort of a small or a large effect on y. Okay, so when we are trying to estimate a model, remember that when we are testing hypothesis about beta 1, we are talking about statistical significance. But when we talk about the size of beta 1, we are talking about its economic significance. Okay, so the size and also the sign of beta j, right? Is this positive or is this negative, or how big this is? And what I want to emphasize is that both of these are important, okay? So, of course, the first thing you want to see is which variables are statistically significant for y, but what is also important is whether your coefficients make any practical or economic sense, and what is the significance of that. So typically what happens is then when we have small data sets, then we might encounter large betas, large effects, which is to say we have a large effect of x on y, but these are fairly imprecise, okay? And these turn out to be typically statistically insignificant. However, when we have large data sets, we get estimates that are statistically significant but are not very large. Okay, so we may get some small values for beta hats, but these are going to be statistically significant. Okay, and this is usually the case. So that's why it's always good to have a large data set so you can actually make some sort of precise inference about the effect of x on y. And here's an example. So let's think about this carefully. So let's say you have a large cross-sectional data set that is looking at the effect of, and this is a large data set for teenagers, which is looking at the elasticity of alcohol demand with respect to price. Okay, so you basically have some sort of a model in which you are trying to estimate the elasticity. Okay, so this is the price elasticity of demand, where we are saying that what is the, so for example here, we can say what is the, on the left hand side, the alcohol demand, and you're regressing this on the price. Okay, and we are interested in this, and this is probably log of alcohol demand and the log of price. That is why beta 1 would be the elasticity. Okay, so let's say that we get this elasticity to be negative 0.013 for these teenagers with a standard error of 0.002. Okay, so here we can compute the t-statistic, which is just the ratio of these two numbers. Okay, and that comes out to be negative 6.5. Okay, so we don't even need to look at the tables. We already know this is a large value for the t-statistic. And this is, statistically significant, right? Or statistically different from zero. That's the interpretation, because we are rejecting the null. If we think about the null here, the null hypothesis would be beta 1 equals 0. And here we are saying that since the t-statistic is negative 6.5, this is a very large value, much larger than the critical values that you would get at 1% or 5%, then we can reject the null, which is saying that price has no effect on alcohol demand, in favor of the alternative, that actually the effect is different than zero. Okay, so the effect itself is captured by this coefficient here, negative 0.013. But this is a very small value, right? It's 0.013. So here we are saying that the estimate itself is very small. So how do we interpret this? We can say that a 10% increase in the price of alcohol reduces the demand by an estimated 0.13%, or a 1% increase in the price causes a 0.13%, 0.013% drop in alcohol demand. Okay, and so the idea here is that this is a very small effect. So what is the bottom line here? The bottom line is that you should not fixate just on t-statistics. So don't get too happy if you just get significant variables. You should also try and interpret what is the effect of x on y by looking at what your coefficients are, the sign, whether it makes intuitive sense, or the magnitude of it. Okay, is it a small effect or a large effect?